And we also use the package called Ebitan, which is a game engine package. And we made a game that creates a curve when I click the mouse button and move my mouse button while it's pressed. And it was a simple game because it has an interaction between the user and the game. But I used the function which is deprecated now, which means that it's not advised to use this function because it will have some error in the later version. So I'm going to change this a little bit to my custom function. So I need to draw the curve, draw the line, the straight line pointing one pixel point to another pixel point. So how should I do that? Here is the way. So let's say draw line. I'll define a new draw line function here. So what's the signature of this draw line function? You can see that I'm going to take 5 arguments here. I'm going to take the screen object, which gives me the data that I can manipulate to change the color of pixel. And I'm going to take 4 integer number, which means that the first 2 is the horizontal and vertical index of the first point, and the next 2 is the second point. And then I'm going to use that. I'm going to use that in here. So instead of changing it to float, I'm going to just simply put the integer coordinates of my pixel point. And okay, so let's put another argument because I want the color. So color element here. Okay, so what do I want to do? First, I want the increment. How big is my horizontal axis and horizontal span and vertical span? So I take the difference between the x-coordinate and horizontal index of 2 pixel points, and same for the vertical indices. By the way, so if I don't have any changes in my coordinate, I don't have to draw anything. I don't have to go through anything. So I can just set my color at the beginning, the starting point, to be the designated color here, and then finish the program, finish the function here. Also, if the span that I choose here by taking one from another is negative, I'm going to change it to positive because I only want the size of the horizontal span and the vertical span. So what I'm going to do, I'm going to make it into positive if it's negative, and same thing for here. All right. So, and then I'm going to define my the number of subdivisions. As I said yesterday, I'm going to take the size of pixel, horizontal or vertical, whichever it is bigger, because that's going to be my number of subintervals. So first I take my dx to be, so dx is the number of pixel that spans from the one point to another, but I just take it as for now. And if it happens to be that the vertical span is bigger than the horizontal span, I'm going to replace my d to dy just to make sure that I get the bigger span. So forgot this one. Okay. Okay. And now I get the number of subdivisions that I need. And then what I'm going to do is I take the division of each coordinate as if the index are real numbers. So for I from 0 to d, I increase my index I, and I reassign my coordinate x and y as follows. So x is increment of horizontal index. So it starts from x0, right? x0. And then I multiply, so I should change it to everything into float. Float x0 from float I from float x1 minus x0 and divide by d. And actually I have to include my d. And same thing for y. I do the same thing for y. Okay. And then what I get is final answer is final coordinates in float, in real number of my point, which is exactly subdivided into equal distance. But what I really need is the index of my pixel point. So I need to reconvert into int value. So not using x and y right like this, but I'm going to convert that x and y into int value and I'm going to color that pixel point with the designated color. So that's it. So that's everything for everything I need to get the line drawn from one pixel point to another. All right, so I think there's no error right now. So let me run this code, whether this works. So yeah, you can see that the line is drawing continuously, and every time I re-click the left mouse button, it can create a new line, and yeah, it works fine. Okay, so what I'm going to do is make a real game. Let's say, I think I showed you before, I'm going to make a game that throws the ball. And I'm going to use the easiest differential equations that I can think of, which is just free fall. So before you make a game, what you need to plan is the scene. So every game has a scene. When you open a game or run any program, it gives you some display in a window, and when you click it, it changes the display. So every display is considered as a scene. So I will have a three type of scene. The first scene I will expect is to have a ball, which is just a circle, sitting there, and I want to have a mouse interaction. When I click the mouse button, I want it to show me the line connecting this ball to the point where my cursor is. So that's the scene 1. And the scene 2 is when I unclick my mouse button, I want my ball to move along its trajectory. So there where I used the differential equation. So in this scene 2, that I will call it scene 2, I cannot interact with my mouse button. It automatically it changes its figure. But anyway, this will just show me. So I'm going to just draw to depict what its motion is. And it's an animation that's moving along the frame. And the last scene, scene 3, is when it lands on certain point. And then, so when I click the mouse button again, I want the scene 3 go back to the scene 1. So basically, this is all has to be considered, and because they behaved very differently. You see, scene 1 interact with my mouse button. Scene 2 doesn't have any interaction, but it has automatic changes in its figure. And scene 3 has nothing change. It's nothing change in display, but it will take my mouse input when I click my mouse button so that it can change it back to scene 1. So these are all I need. Okay, so what I need to do is information about scene, where I am right now. So I need a scene vector, a scene field, and you can assign any data type for scene, but easiest way is just to assign it as an int value. So scene 1 will be, let's say, just Well, it doesn't matter what number it is, but I'll define it as a constant. So constant is constant scene, or what is it? Scene, first of all, or ready scene. I'll show you some technique that I can do it here. So scene ready and scene game and well, not scene flow, scene throw and scene land. Okay. All right. So maybe I don't need to use this because I don't want you to confuse this. So 1, 2, and 3. So I just assign a constant value with the variable name scene ready, scene throw, scene land, which corresponds to scene 1, scene 2, scene 3. So I'm going to change that value, change the value scene with these constant values to indicate which scenes am I at. So let's see. So when I make a game, I want my scene to be start at the scene ready. Okay, so that's when I first make my game struct. I want my field to be initialized with the value scene ready. That's where where I want to start. So I need to this. I need this, and in the update, what do I need to do? So first of all, I need to interact with my mouse button depending on which scene am I at. So if, so let's use a switch here. So switch is something that see the value, something that connects our code to whichever is relevant. So when you use the switch method, a switch command, it look up the value inside is in this variable and go to the case where the values matches. So if G scene is scene ready, I do whatever is written below this case. And then if it's scene throw, I do whatever is in below, and scene land, I do whatever it's in below. So in the scene ready case, I want to take the input of mouse click, right? So if, let's see, if ebiten is mouse button press, left mouse button, then what I want is I want to record my cursor position so that I can draw the line between the ball and the cursor, right? So I need a place where I can store the information of my pixel. So I'm going to change my field name a bit here. So it's pixel, not pixels, because I only need 2 coordinates. So I'm going to record my pixel position here. So X and Y is ebiten cursor position, and I'm going to store the X and Y index information here. And that's basically it. But I think I need one more thing here. So I want my scene to change to scene 1 to change to scene 2 when I release my left mouse button, right? So I need to record my mouse clicked position, but I also need to detect whether the mouse button is just released. So it's in the input util, then is mouse button just released. So it detects whether I just unclick the mouse button. Okay? And then if it's the case, then I change my scene to the next scene, which is scenes row. Okay, that's basically it. And what happens at the scenes row? Well, basically nothing happens, right? But not that nothing happens, because you see, I have to change my position of ball. I have to change my position of the ball, and every time I have scene 2, I have to update my position of the ball. So there should be an index, let's see, where the ball is. So I'm going to use the float 64 as a ball position. And so the ball is moving horizontally and vertically in both directions. So in the horizontal movement is governed by how much I released my mouse button in the scene 1. So the length of horizontal length of this line will be the speed of the horizontal movement, and the vertical length will be the vertical speed, the initial speed. So I need to update my velocity, initial velocity, or just velocity. So velocity as to float here, to record here. So let's say just velocity here. And okay, so the ball, the x coordinates has to be updated. So ball 0 plus velocity 0. Now there should be some factor that I need to adjust here, because if I just take the velocity as the number of pixels that I have, then it's too fast, and I'm moving too fast. So I need some factor that I need to divide out to make it move slowly. But let me just put it this way and change it later. And how about the y movement? How can I change the y movement? So it's also the same as the movement in x, but in the y movement, there is a gravitational force that is moving downward, right? So I need to update my velocity to decrease. Let's say by gravity here. So gravity is a constant, so I'm going to define it here. So constant gravity, let's say I'm going to, so it's not 9.8 because we are making a game, and the game XY plane is not the XY plane in real world. So I'm going to just put a number in, just random number that I'm going to adjust later. So the important thing is the gravity is just a constant, and that is going to change the velocity in the vertical direction. So you see, I'm changing my position of ball, and then I also changed my velocity. You can move around this position, but that's maybe like changing the velocity a little bit and then update your position later. And all right, so when does scene 2 ends? When does scene 2 ends? It ends when the ball lands on the ground, right? So you need to know when the ball lands on the ground. So if it lands on the ground, you have to change the scene. So you have to detect when a ball is landing on the ground. So if the vertical position of the ball is, well, I'm going to take the position of the ball to be the center of the ball. So if the center of the ball is below the radius of the ball, then I can consider it is landed on the ground. So if it's below the radius, then I'll change my scene to be scene land. So again, the radius is considered to be the constant. So I'm going to, let's see, put another constant here. Radius to be 5. So it's in pixel, 5 pixel radius. Okay, just to make sure that I've commented here. Okay, so what happens in the scene land? Okay, so I think that's a scene 2, and that's in the scene 3, scene land. It doesn't do anything, but it should detect my mouse click. So if I click the mouse, it should immediately change my scene to scene 1. So if mouse is just pressed, then I should change this scene to scene ready. Okay, so this part is the previous part, so I can delete this and let's see. Yeah, so that's it, right? So that's all I can, all I have to do is, and okay, now let's go to the drawing part. So at any scene, what I need to draw is the ball, right? I have a position of the ball, which is going to be updated anyway. So I need to draw the ball. So draw circle. I'm going to define draw circle method later, function later. But draw circle at the pixel position with radius. Maybe with a color, white. Right now, white. Okay. So let me define the draw circle right now, so that we don't need to forget. So how do you draw the circle in a pixel position? So first, it's the same thing. So you have like these discrete pixels. You want the shape to be as close as a circle. So let's say your position is x0, y0, and your radius is r. Consider these all be a real number, and you want to subdivide your circle into a sufficiently many number of subdivisions, and then convert each coordinates of the point on the circle into integer coordinates, and then you draw it. So here we have subdivision n to be circle here. Yeah. So here, and maybe a bit here. So I'm going to assign my n to be the number of subdivision, which is 100. And let's see, x0 and y0 is going to be the center of my circle. Now, the input is in integer, but I'm going to convert it into float. Okay, and then from start to end, it's an n interval, so I need to go all the way back to here, and I'm going to define my x and y coordinate of the point on the circle, which is the center plus the cosine value, right? So a center plus the radius of cosine of 2 pi I over n, and y, same for y. So I used the package math, which contains the function cosine and sine. I think we covered this some before. And then once I get this coordinate x and y, I'm going to set the pixel position as close as to the coordinate x comma y with the color, designated color. And that's my drawing circle function. So again, going back to the draw method of the game, every time I just draw the ball. And then what I need to do to draw more is, well, I don't need to draw anything more than ball in scene 2 and scene 3. But in scene 1, I need to draw the line connecting the center of the ball to the cursor position, right? So if the scene is not throw, is, what was it? Ready. Then I need to draw line connecting the ball position to the cursor position with the color. Draw, no, not one. I don't want here. I want here. Yes. And the color is going to be white. And okay, so ball position is in float. I need to convert it into int value. Okay, yeah. Let me change the lines, make it clean. Okay. All right, so that's my drawing function, the draw function, right? So that's all I need. Okay, so let's test out. So I'm going to run this code, and I'm not expecting to. Okay, so I have a ball right here. So now I know what I mistaked here. So I I made my initial position. I didn't set my initial position, so it was set automatically to 0, 0, which is on the left top corner of the screen. So in the beginning, I need to set my ball position, ball, to be, let's say, bottom of the screen. So bottom means the, all right, so we need not the center at the right, in the bottom corner of the screen. I want the radius, I have a radius of the ball, so I need radius, there's a float 60, so it's okay, so radius, and the width is 240, so 240 minus radius. That's the position of my ball. Okay, so let's run this game again. Okay, the ball is still here. I think now white ball is still there. So I think I made mistake here, and that's okay. I want to draw the circle. Draw the circle. Oh, sorry. So not pixel coordinate, ball coordinate. Sorry. So I want ball 0 and ball 1. That's the x and y coordinate of my pixel. And okay, so I'm going to change this to x and y, not x and y. So I and j, no, maybe not I and j, sorry, x0, y0, int value. And I'm going to change it to x0 and y0. So I made a mistake on here, so I just want to change it to whatever makes sense. So I'm going to change it here, y1, y2, x1, y1, y1. All right. So it's a float type. So okay. So I'm going to use just the same coordinate I have here. All right. So that now I'm good. All right. So and then let's run this again. Yeah, now you can see that the ball is in the center, at the bottom left corner here. And it's scene ready. So if I click a mouse button, you can see that the line is drawn from the center of the ball, and it's changing as my mouse is changing its position. I didn't release my mouse button. Let's release what happens. So when I release, okay, so I think, okay, so now what's happening? So so you see that the pixel coordinates are decreasing when I go up. So it's opposite to our intuition in XY plane. So in here, let's see, in the update function, I updated my position, the Y position of the ball, but I added my velocity, right? So my velocity has to be, what is it? It has to be subtracted from my position in order to get the movement to the upward, right? Because if you have a positive velocity to the upward direction, then your pixel coordinate, vertical pixel coordinate will decrease, right? So that's what I have to change. And okay, so also let's work on the velocity. So when you release your mouse button, what you need to do is record your velocity. So your velocity is going to be, first x-coordinate velocity will be how much your cursor is positioned horizontally from the center of the ball. So you just take away the pixel position and the ball velocity, and then there is a modifying factor. Let's say, make it a constant here. So the factor here. And I'm going to use the factor of, let's say, 20. I think 10 is too small. And then I also need my y velocity, but in this case, so if my cursor is above the ball, my y coordinate is smaller than the position of the y coordinate of the ball. So I need to change the order of subtraction. So I need to change it from ball position minus the cursor position. Okay, and divide by factor. So I recorded my velocity and I subtracted, and the velocity is also decreasing by gravity amount. And yeah, so that's what I need here. Let's see how it looked like now. So I'm going to rerun the code and let's look what it looked like. So now I have a, okay, so now it's a bit moving. Okay, so it takes time to land, but it's already outside my screen. I cannot see it. So I think it takes a long time to land. So let's make it a factor a bit bigger because its factor is too small. The movement is too big. So let me make it into 100. So let's see. Okay, so I think it's somehow going infinitely downward. So let's check about the condition when it changes to seen land. So if the ball position, oh, by the way, so yeah, and I also made a mistake. I thought it was XY coordinate. So if the ball position is the bottom end of the screen, that means it's way bigger than, let's see, 240 minus radius, because we have a 240 pixel in the vertical side. Then it means the ball is, going below the ground. So let's rerun the code again. Then I think it will work. Yeah, now it's stopped. So it's in the scene land. And when I click this again, oh, okay, it's not repositioning, but that's okay. So now I can make it jump continuously. That the ball position is not updated. Still, I'm working, but you can also go backward here. So if you want to make it a bit, jump higher, then you can adjust your gravity constant. For example, I made a gravity constant too big, I think, so that it doesn't go higher than what I'm expecting. So maybe let's make it 0.5 instead. 5 times, no, it has to be smaller, right? I think it has to be smaller than this. So 0.05.